Okay, so we have a situation here where we're going to be analyzing this lab image, and I'm going to run my unzip. And I'm just going to expand it out. Okay, so I'll give you some background. Can you guys see this screen very well at all? It's not that great. Let me try and put up my here. A little better. The video is perfectly clear, so if you can see this, you'll be able to see it even perfectly in the video, because the problem with this is the projector here is not what I'm seeing on my screen. So what you're seeing on your screen on your own laptop is exactly the same with my own screen here. But the projector here is not as all that great. All right, so I have this here. I'm just going to quickly remove lab 3 image here. No, not this one. Okay. Okay, so the first thing that we're going to do, as we've done in the past before, is to run volatility against it. And I'm going to assume that you're sort of familiar with what we've been doing in the past class, so I'm going to try not to waste a lot of time here. As you have known, we generally like to start from our process, right? The background story about this system is that on this system there's a strange behavior that is noticed. Okay? The administrator tried to investigate it. They used 2 different tools on it. Okay? Number 1, they use Task Manager. When they use Task Manager on this system, it shows that there are 0 process running, which is not possible for a Windows system. Does that make any sense? You've got to have at least some process running. Now, when they use a task list, you will use it starting from next week or the week after, is another tool. Task list says that there are 20 processes running. So you have something very, very strange. So the administrator decided to report it, and this image was of memory was captured. So off we go. We're going to try to analyze that. So we have PS list. Okay. And as we often do, we run it like this. And so I've shown you guys in the class. Then we run our PS scan, isn't it? We run our PS scan, but better than running the PS scan, I've told you guys you can run PX view, right? If you're going to run PS scan, you might as well just run PX view. And we want to quickly get to what we think might be a little strange. Again, I'm getting straight to the point here without spending a lot of time analyzing what is wrong. Or what a PS list is, because we've done this in a class before. And very, very quickly you can begin to see some things that might appear to be strange. Like we have a command shell here. It says it's false. Over here it says it's true. This one says it's false here. WMI PRVSE says false here. Here it says it's true. And then we have services here, okay, that is eating here, but then PS scan says it found it. Here's another false here, win logon. False here, says it's true here. Here's another one, command prompt here. We see a lot of stuff that says false here, WordPad. So this is not very difficult to examine. I've walked you through the process of hiding a process, right, by unlinking it with other process, correct? And that is simply done by removing the fling, or flink rather, and the blink of the process you want to hide, and connecting it with the process that is in front. That's already covered in our previous class, in extent. Now, the general terms for this is DKOM, DKOM, which stands for Direct Kernel Object Manipulation. Okay? Remember that the list of process that is coming, that you're seeing from your task manager, is coming from the output of eproc data structure that you have the API walking through the list all the way down and coming with the enumeration of that eproc data structure. What's that?
That's the end of the download.
It's in the previous, you've got to go to, were you in the class last week?
I was out for
Oh, okay. All right. So go to your previous, I think, we have module 5 or 4. You will see where we have all the images located.
Oh,
all right. Yeah.
Mm-hmm.
So that's what generally happens. You have a rootkit that is modifying the kernel memory to conceal the artifact. So that explains the discrepancy between PSList and PSCan. Volatility can further locate your DKOM. And when I mean DKOM now, you understand what that means. That's direct kernel object manipulation. But volatility can help you to uncover additional stuff by running through some of additional plugins. One of the plugins that is going to be of interest to you is driver scan. Okay? And what it does is to locate device driver on the system by scanning the memory image file. Remember what I told you earlier on, that one of the quickest way for the bad guys to essentially gain access to your kernel is through device driver, because device driver generally writes into the kernel. And that's why sometimes it's very dangerous to just download any drivers for any tools and just run it, because you could be essentially affecting yourself. Does that make any sense? So you generally don't want to download any driver you don't know. As a matter of fact, there are some systems that generally do what they call code signing. They sign their driver or their code using certificate. That way you will know when you're trying to download a driver that has not been signed by somebody that you trust. So I'm going to come over here now, and instead of typing my PSX view, I'm going to type driver scan. Okay? And I'm going to run this. I'm going to pipe this into more. And looking at this, you can then begin to take a look and say, do I see anything that is weird? Now let me quickly ask you, take a quick look at this thing. And this is your physical offset here, so don't forget that. So, do you see anything here that kind of, maybe makes you wonder and say, what is this? Anything? Akamai, there you go. That sounds weird, isn't it? Isn't it? remember I told you guys in the class that the way you're going to hide a process, one of the most common ways to do it is to perform the attack that I call, the root kernel object manipulation, right? Because the eproc data structure resides in the kernel of your OS. So what is the easiest way to get into your kernel? Drivers, isn't it? Drivers. So that's why we run drive scan. So you have this right away as something that probably just jumped at you. And you can probably walk and say, this name might have some things to do with some of stuff that we've seen before. Do we see any of this before in the past? Let's take a look at this. Go back to your PX view. Because one of the key things that you want to look at is to try to draw some parallel between what you are seeing and what you're looking at. What about this? Are they similar? Huh? Hello? See that? Most of you did not take a look at that because it is not hidden. And sometimes one of the funny things, if you really want to confuse people, is you can just come out in plain sight. Psychology will stop looking for you. You can just have it. No. If that's the guy that everybody's looking for, he's not going to be out here, right? So the guy can just say, I hide. Because if I hide, they're going to think I'm bad, right? And then look at it. Here is mine. You've got to go back and connect, the dot. So you saw the connection between the mic here and also the drive scan over here, mine. You see that? Hello? Okay. So, in addition to that, one of the things we can also do to get another perspective on kernel module drivers that are loaded in your system is to examine the modules. Okay? And this works by generally traversing through a process that loads module on your Windows system. Yes, go ahead. Again. So we have this correlation. The next thing I'm going to try over here is then I'm going to try and type modules. And I'm going to pipe into more. And with modules behave like process. And I can see, look through this in case you find something that might be out of order. I haven't found anything. I can just kind of look through to see if I find anything that's out of the ordinary. So keep looking. One thing about the modules is, can somebody tell me one thing about the modules that you don't necessarily get a lot of it from the drive scan? Tell me one thing about the modules that you will find very useful. The pad. And what do you see here? Huh? Mic. Okay? Now all of a sudden you see mic, and now you have the path. You also have MK tools. But here is Mike here. It is important that you look at these carefully because they offer you a very, very important and valuable insight into what you might be dealing with. Now you know where to look at on your system, right? Look at this also. Look at MS Direct Exorcist. That's another thing that would jump at you and say, oftentimes, look at something, look for anything that is not running from your system root, system 32, because this is where most drivers run from. You understand? You got it? What is a driver that is running from your C, not system root, right? Not system 32. Look at that. So you want to kind of look for this outlier because they might be giving you a telltale sign of something. So now, if I were you, I'm writing this one down. I'm writing this thing down. I'm writing this thing down. Drivers don't load from drive C. That's another thing you need to be familiar yourself with. Okay? They are always in system 32 folder called drivers. You see that? You got it? So when you see something running from this, then you're beginning to wonder and say, what's going on? So you have all these, you know. The next thing I will do is for you, you can go on and search. You can even go online and search. Say you want to go online and search for FU because you know they're using rootkit. And you find a lot of stuff about FU rootkits. You understand? You can learn a little bit about it, how it works, you know, technical detail. Alright, you can look at the system information and so on and so forth. Let's go back to where we were. FU. This is what I searched. Okay. So the next thing, one of the things that you might want to locate some artifacts, just like we did earlier on, for indication of compromise, or for something that will help you to do a further investigation on this. And one of the things you can do here is to run strings. And when you run the string, you want to find out additional information that might be associated with the tools. When you do this, try to run it searching for it both in ASCII and Unicode. Okay? ASCII and Unicode, because some characters are just you might not find if you're just looking for ASCII alone. So the first one I'm going to use over here is Unicode, and I'm going to type encode equals to 1, and I'm going to point you to where my image is located. And I'm going to send this one to grep. And there's something I'm going to do over here. If you're familiar with the grep command, this is essentially, and I'll walk you through what this does later, This is actually saying look for 2 lines before and 2 lines after. See dash B2 and dash A2, right? If I were to say dash B3, that is 3 lines before. You understand? If I say A3, that would be 3 lines after. Does that make any sense? Hello? So you use this when you are grabbing for something, but you also want to gather context of those keywords. Are you getting what I'm saying now? So if I'm saying look for money, I can say, you know what, grab 2 lines before the keywords and 2 lines after that, because I want to see what they're talking about. Okay? Alright. So that's A2 here, and I can put a single quote here and say FU here dash PH. That is the information we gather from our artifact that we looked at. Another thing you can do is to pipe less. Let me see if I'm not getting something wrong here. Sorry. So strings dash encode I'm not sure I'm getting my command here. So I'm spitting in a lot of stuff on the screen here. So what I'm going to do here is I'm just, again, just strings dash dash encoding dash L, right? That's Unicode. Lab against the image. Okay, I'm creating a string. I'm saying I'm looking for Unicode strings. And I'm piping that into a grep command. And I'm saying I wanted to grab. This is a keyword. This is what I am searching for. FU. And remember that I told you guys some of these tools, they have bad language in them. Now, I kind of told you guys earlier in the week, and it's going to get worse. Okay, especially when you're grabbing real sample in the wild. They don't often, you know, these are not people, nice people. So, and I'm saying, don't just grab this command for me, keep these strings for me, because I need some context. And I'm saying, grab 2 lines before and grab 2 lines after. Yes? Yeah? Remember, that's the part of the string. When I went to the website earlier on, yeah. Remember, I went to the website earlier on to kind of learn more about these particular tools. Essentially, what we're just doing there is just to kind of look for strings that generally are common with this particular stuff. Does that make any sense? So, and one of the things that I'm looking at is, see, look at this PH, you know, PhD, to hide the driver. PH here, to hide the process with the PID number. Does that make any sense? So, and this is common, we learn more, so you get a little information, you go and search and learn more about the tools. and then you come back and leverage that to run. Does that make any sense? If you even look on this side, they show you how they run this thing. If I come over here, look at this. If I say FU, again, pardon my language, it's not my language, it's the tool, okay? So if I say FU-PL 100, okay? So what does PL does? PL to list the named driver in the debugger view, okay? That's PLD. And PL is to list the first number of process. And see, when I do this one, this just kind of do this. All right? And I can see my calculator here. See that over here? And with the help of this, I can do it in such a way that when you run your task list, you see what your calculator is showing. You know? So you can make it. So this thing lists all the process. And I can show it over here. FU, here is this one. Here's my system 4, system blah blah. And all these things go all the way down here. And you have my calculator running at this. Number of process running, 32. Then the next thing that I run over here after, you know, you have this thing working, you can see this guy 1272. Look at it over here, 1272, 1272. In the screen below the screenshot, you have hidden the process 1272 by running, you know, PH 1272. So now, all of a sudden, you say FU -PH 1272, right? Which is your calculator's processor. When you run your task list here, what happened? It's hidden. You understand? So you can use these tools to hide a process. Okay? You can play with it on your own later. So this is where I get the idea of running for FU-PH, because that is the argument that you will have to use to hide the process with a given pre-ID number. So if I know the process ID, I can hide it just by running FU. Okay? All right. So I'm going to run this into more to slow it down for you. And now you can see by searching for it, grabbing 2 lines before, grabbing 2 lines after, then you can begin to see, you know, where these things really are. See the process that is hidden. See that? 932. You see that? Somebody is hiding that process. Okay? Process 1648 is also been hidden. Process 1744 is been hidden. 274 is been hidden. 11 is been hidden. 1172 is been hidden. 1012 is been hidden. This should make your exam a lot easier, because if you're paying attention now you can see, look at this CMD. He's hiding it. That's why when you run PS list, you couldn't see it. But when we run PS scan, we could see it. Because he tried, well, not he tried, he actually did hide all those processes. And then you can go furthermore to just grab any. Now you can see that this guy here has something to do with Akamai. It's run system, I've forgotten the name of this command, but it's a Windows command. Okay? And if you run SC, I'm not sure whether it's still in Windows 10, but SC over here, let me go back up here. So if you run SC here, it's a command line program used for communicating with service control. You understand what I'm saying? And if I want to, you know, see what particular services is running, I can use this SC to actually view a lot of my services. Okay, so it's very, very easy to kind of find out the state of a particular service. You can stop a service. Okay, you got some argument. You can see some of the examples over here where you could actually type a particular service, and then it would kind of running. You type query here, so you could see QUERY. So now you can see it just listed all the services that are running on my system. You understand that? So you can walk back and see what this guy is actually doing. All this command is typing them, right? So this is him looking at the status of this particular process that he's running, checking the status, refreshing it, then go ahead and hide this. Then it did something. Look at this, command exe, and then what is he doing here? He's mapping a network drive. You see that? Hello? So it's important. The reason I'm showing you guys this one is because you have to tell the story for your midterm. Don't just take a screenshot and spit it out. This is what this guy is doing. I'm not going to accept it. You have to tell a story. What is this guy doing? And tell your story without necessarily including all these jargons. It's you to look at this and say what this guy is trying to do in a simple, sensible way. Okay? So you can look at more and more stuff that this guy is doing. You can even look at the location on the hard drive where he's actually hiding his tools. You can see them as this guy runs. You can see what he runs CMD. Then he runs CMD, hide 1744. Okay? And that answers the question why your CMD is eating. And then he hide all these things, all this command. He types it. And then come over here again, 628. Then it goes to your Windows. And what is this guy doing over here? Huh? Yeah, but what is this? What is this part? What is other? This is Windows part in a way, more or less, right? This guy is adding itself to Windows part so that it can run. Right? Look at it. This is Windows. C, Windows. System tells you can see semicolon separated. That's what Windows part look like. Right? So look at part here now. If I type part here now, see my Windows part. You can see how they start. You can see how they are separated by semicolon. Right? Another semicolon, right? So in a way, this guy is looking at system part and is adding itself to system part. That way, you can run this command from anywhere without having to go to a particular place. Does that make any sense? So that is, for you, is a valuable information that you want to know. Okay, and you can locate all of these things and see that they match up with the PID. So look at all this thing over here, 932.168.1664102, blah blah. If I come over here and do what we did earlier on, go to PS view again, because then you want to match them up. Your story you have to match. So then you can begin then look at what is 932. If we can find anything 932 here, provided it's not eating already. Okay, because if it's already eating, then you wouldn't find it. Because there's a lot of stuff over here that the guy just pretty much, completely, hide it from us. Look at 272 here. You see that? Hello? You see 272 here? 272 here, that's why he's hiding it. See why it's showing false here, but true? Because he hid it. You got it? So it's going to be your job to mash all these things together. 1744. That's because he hid it up here. 1172. That's because he probably hid it somewhere on 172 here. You understand? So it's going to be your job to put all these things together and be able to say, we're able to prove conclusively that this guy is hiding stuff. Now, another thing I was going to show you here that I think might be of value to you is there's a plugin that allows us to actually look at consoles. You can actually see the command line that somebody is typing on the keyboard. You understand? So with this command line, I'm going to pipe this into more. You can actually see what the individual is typing at the command prompt. You understand? So that takes you right to the front of the attacker's keyboard. You understand? Hello guys. You guys are quiet. Are you tracking? Okay. So you're good. So this one takes you right to the attacker's keyboard. And you can see the guy switch his directory, change directory to tools, and they type dir command, you know, cd fu directory over there, switch to directory fu underscore rootkit. You can see everything he typed as he was typing his keyboard. You can see everything. See that? You can even tell he's on Windows XP. So everything that happens on his keyboard, you are seeing it line by line. You understand? Any question? Yeah. So if the guy is if he has a console access to your system, you can grab everything. You may not see the remote one, but the console one you are able to see. Okay? So what you're getting from here, you're seeing the attacker's output. You're seeing, look at all this now. I can see what he's typing. I can see his output. There is another plugin that I want to show you. And this one, unlike the consoles that shows you the output of his command, this one, we call it CMD Scan, does not show you the output of the attacker's command, but it shows you what the attacker is typing. Okay? Shows you what the attacker is typing. And that gives you a great insight into all of his activity. So we've investigated the FU PH now because it's of interest to us. We can, as a matter of fact, go back and do the same thing. But this time around, we can focus on mic 022. Okay? Can come back here. Mic 022. Okay? .exe. Got it? And this time around, we can expand our scope. 10 lines before and 10 lines after. Okay, that just kind of expand the scope a little bit. Of course, you're going to get a lot of stuff, but you can always pivot. Then you can see the web client. Begin to look at, the name of that particular process and any additional information that you can gather from there. And you can see the more we search from this, the more we gather more information. We looked at this Unicode. We can go back and look for ASCII. without encoding here. Then without doing that, see, all I'm getting out is just my ASCII stuff. Okay? And I can see a lot of VAD, mic022.exe. You can see hidden registry key. Look at this. What do you get here? What's that? Password. Password equals to mic-rule-z. If I were to give you this question in your midterm, I will be looking for that. I'm giving you some really idea of how to go about your midterm. Okay? You see that, you see something different when you look at, when you search using ASCII. You see something different when you look for something with Unicode, right? And you've got to look for both. So now I can see my file name, driver file name is this, the other file name is also this one as well, service description, powerful NT rootkit, service display name, this, service name, file mapping, password equals to mic rules. Very, very important. Okay? By searching for additional information, you might get, artifact that will point you in the right direction. In this case, we're able to find some interesting details, concerning this file. Okay? Any questions, guys? With the ASCII command, I can go through all the way down, So there's this stuff over here.
What command did you use to do that?
For ASCII? Oh, the only thing I did was very similar to this other one. The only thing is I didn't put encoding. This one is just allows me make sure it's Unicode. So without this, I'll be searching for just my regular ASCII. You understand? So here's the command that I type. Same command, but look at the encode. Encoding is not there anymore. By putting dash encoding equals to L, I'm saying it's Unicode, but by just leaving it over there, just going to run some simple, And by doing this, I got some very important information. That, as a matter of fact, powerful anti-rootkit. And again, just like we often do, you can go to Google, and go online. Be careful where you go though. Okay, some of these guys are not nice. If you mess with them, they will hurt you really bad. Okay? Then you can get a lot more information about these particular files. And one of the things I would quickly just show you, let me see if this one is good. You can read this on your own later if you have a lot of time. But there's something I'm going to quickly show you here concerning this file, is that it's got some INI files. It's got some eating tables. And if you keep looking on this file that we get earlier on, you will see that there are some things there that will give you some key information. Look at this: hidden reg value, hidden whatever, hidden port, hidden table, powerful rootkit, hidden ports here, hidden tables. So you have all these keywords that now, look at this, hidden tables. So you can then begin to use them to find out and look at all the stuff we hide. Look at all the stuff the guy just, mess with. For the most part, this is mine, this is WordPad, iExplorer, WordPad, calculator, and so on and so forth. Now, let's go ahead and search for this now. We'll go back here, and this time around, we're going to go ahead and look for hidden table. Okay, hidden table. And look what we got. When I look for hidden table, is it better to use uninstall or to use netstop service name? I really love this program. Can I support your work with a little donation? Is there any chance to hide C:temp and not hide C:temp? I can see the password is infile in plain text. How is this possible? If I have a process that is hidden table and it listens on a port, will this port be automatically hidden, or should I blah blah? So you can download some of this, you can go through this. I'm just pointing you in the right direction so that when I give you an answer, when I give you your midterm and I ask you to do an exhaustive analysis, you understand what I'm saying? This is an idea of what I want you guys, to do. Can go back here. And then you can begin to look at hidden table here. exe. Those are the stuff that is hiding. And you can even learn more about this stuff, how it works. Alright? Take advantage that I've almost answered pretty much all the heavy lifting. And with this INI, the way this rootkit work, or this rootkit work is anything you put inside your INI, it will automatically hide it. You understand? So the bad guy is using two tools. The first one is the FU tools that we looked at, right? That will hide in the kernel. The second one is the mic. Mic uses initialization file. And anything you put under that INI file will be hidden from task, manager. And look at it, hidden table. What does it do? It says star.exe, right? That will hide just about all your process. You understand? Hello? So the FU, remember, that is a kernel. Pay attention now because you will deal with this in your midterm. The first rootkit is a kernel, that's a DKOM. Why do we say it's a DKOM? Because it's a driver. You understand? It's a Windows driver, and we know that Windows driver have access to write into the kernel of the system. This other one is not a kernel rootkit. This is in the user space. Why? Because it's not writing anything into the kernel. We couldn't see it, it doesn't show up on the drivers. Does that make any sense? This is operating at the user level, not at the kernel level. And the way it works, just giving you a heads up now, you're going to have to read all this stuff that the guy wrote here to kind of grab that. But I'm boiling down for you is these tools has what they call initialization file, INI. And the way he hides it, whatever it is you want to hide, you put it under what they call hidden table, and it will hide it for you. So you can see star.exe, that will hide it. The guy reading, that's in root process. Anything that has mic 022 star, it says hide it. Task list, hide it. CMD, hide it. Hidden services. You see, the guy was kind of like really means business. You know, hidden registry value, hide NTFS, hide OBNN, /10. So if I ask you in the question, in the midterm, what is the guy trying to hide? What are the things he's trying to hide? You've got to be able to kind of like dig through this. And, fortunately for you guys, you really don't have to dig anymore, because I already just undug everything out here for you. If you look at your tax manager here, everything you see here, they are all in exe mode. All the process are exe if you look at their name. I don't know if I can really show you the name here, but if you can see the actual name of this thing, all these things that are running here, they are all exe. In the next class I will show you, so you can see tax, but all of these are all exe. And that's why with what the guy did up here, by hiding on the hidden table here, where is it again? exe here. That's why they cannot find anything when they run the tax, manager. But when they run the task list, they were able to see, about 20. Any question? Any question? Now, how does this work? This work because of what they call API hook. In other words, this rootkit sits in user space. Anytime you want to do something, the API, which is the application programming interface, will take your request, okay, and display what it wants you to see. In other words, your request is not going to where it's supposed to go. Are you getting what I'm saying? Normally, when you run your tax manager, when I do this, tax manager, this output is running through a particular Windows API that talks to the kernel. Since I cannot talk to the kernel directly, the API talks to the kernel, obtain the output of eproc, enumeration, and send it back to me. API again stands for Application Programming Interface. It is what allows two programs to talk together. For example, if you have a database that is using, say, XML, and I have a program that is using, what is the other program that a little bit more lighter than XML? I'm trying to remember now. There's this very common program, very light. Anybody know that? It's a very common program. Let me look it up. It's very common. If you say XML, JSON, okay? It's JSON, okay? So if I have a program that's using JSON to communicate, and the back end, and another program that is using XML, and I need to talk to an XML, and I'm running JSON, well, they cannot talk together because it's two different languages. What am I going to need to get? An API. An API that can take a JSON input, reformat it, and send it as XML. Take XML input, reformat it, and send it back to me as JSON. I don't need to speak the same program with you, the same language with you, as long as we have API. That's what allows platform applications to talk back and forth. For example, I can write a program that allows you to look up the closest restaurant to you, right? And I can say enter your zip code, but I don't have a huge database of Google. What am I going to do? I'm just going to get Google's API that allows me to send a query to Google, get the answer from Google, and port it back into my own program. You will not know, but that's API. Now, the reason I went through all those explanations is to let you know how this works. How come when this guy right-click, his own tax manager, he doesn't see anything? It's because this rootkit has what they call API hook. The rootkit hook into the API, so that when this guy wants to see what is inside tax manager, the API is being intercepted and is displaying back to him what the rootkit is configured to display. But good for us, because with volatility tools I can actually look for API hook that might potentially be around. So I'm going to type API hooks. And what this one is going to do, that's going to detect inline as well as other API hooks in user and kernel mode. And for us here, I'm only just interested in the user inline hooks. Most of your API are legitimate. You're just looking for the ones that may be not so good. Gonna wait a little bit and see. Normally we'll run a little faster, but most of us are running this on Amazon with roughly just 1 gig of RAM on it, so we really don't have a lot of and I'm only concerned with mode, the one that's running in user mode. You understand? Only concerned with one that's running in user mode, and you can walk through and see any of these operation to kind of view which one of these do you think might be malicious in one way or the other. Look at the process, however. Look at the process, compare the process to some of the ones that we've had before. That will give you an idea of what you want to look at. Okay? Don't forget the process. That will guide you. Again, only focus on the user mode. Okay? I'm not going to tell you anyone particular here, but look for the user mode. You're going to see a couple, and make sure look for Explorer especially. Okay? Any questions so far now? Any question? So we have, to a large extent, walked through this. You can even dump some of these VAD, but we're not going to go into that. I'm going to stop the recording now. That's some